Hey guys, today we're going to start working on a project that I've been wanting to do for a little while here, and that's a sort of sunrise simulator alarm clock type thing. So, you can't actually buy sunrise simulation alarm clocks, or whatever you want to call them, on Amazon for about $50, but and those are kind of neat because they do change color according to what the sunrise would actually do, but they don't seem like they would actually be all that bright. But what I want to do is I want to take this alarm clock here. We'll put some outputs on it so we know when it actually goes off, or have some idea when it actually goes off. And I already have some white LED strip. I'll show you in a second. That actually lights up my room here in the mornings. But anyhow, I'll go ahead and show you that LED strip first, and then I'll come back and I'll tell you a little bit about this alarm clock and my plans for the project. Alright, so I apologize for the poor lighting in this scene, but anyway, I've got 12-volt power coming in here for the LED strips, and then that goes into this little switch box that I made up. Anyhow, this first switch turns on a set of LEDs that are up above here. So, and then the second switch turns on LEDs that are behind the headboard here. And this kind of gives it a nice looking glow effect behind it, but also need to retape this so it actually sticks down here, but that goes up here, and then the LED strip just fits perfectly on the edge of this trim. So I just ran a strip across the top of that window there. And the original purpose of putting these in was to have something I could turn on in the morning and not completely blind myself with the full room lighting. So for that it does its purpose quite well, but what I'm thinking now is I can use those for the sunset or sunrise simulation alarm clock. Alright, so back at the alarm clock here. What I'm thinking, in order to trigger those lights to start coming on, we want them to fade on really slowly. This is an LCD screen, therefore it has a backlight in it. You notice right now it's actually pretty dim, but if I start hitting buttons here, it should actually brighten up quite a bit. Maybe if I turn this on. So you see that brightens up a little bit. And what I'm thinking is I can hopefully put some wires onto that backlight and get a sense off of that. So, and the reason why I want to do that instead of like tapping off of the speaker is because this is one of those alarm clocks that it starts off really quiet and then kind of slowly ramps up, which means if I hit the snooze button before it gets ramped up to a certain point, I might, the circuit may not actually trigger. The other thing that I was thinking is to probably simulate our sunrise in about 9 minutes. And the reason why I want to go with 9 minutes is because that seems like the standard time that one of these, like when you hit the snooze button, that seems to be the amount of time that it lets you snooze for, keeps the alarm quiet for. So, anyhow, I'll go ahead and take this thing apart and see what we can find in it. So that should be kind of fun. These screws seem to be conveniently pointed out with little arrows on them, so I assume those are the ones that we need to take out. So I'll go ahead and start working on this. I'm not really sure how this comes apart though. Alright, so that took a little bit of work. I found two more screws behind the little plastic bezel thing for the screen. But there is what I wanted to tap wires onto, those LED, well, those are all just wired in parallel, I'm pretty sure, but that's what it looks like because they all have the same resistor right there. So anyway, you got LED, what is it, 2, 4, 5, 8, and 7, is that what it is? 6 and 7. But anyhow, while we're in here, we can take a look around here. This is a Bluetooth enabled alarm clock, so there's your little Bluetooth module. There's some type of micro-controlling device probably right there, I don't know. That's actually upside down. Sorry for the handheld camera work, that's about the easiest way to get in here. There you go, not really sure what that is. But anyway. Other stuff over here, there's a socket for the backup battery, and then board with a little USB charge connector on it, and some other stuff. The power input and the auxiliary input as well. I unplugged this. It's nice that they put a connector on that at least, so I can unhook it. But I'm going to go ahead and solder a couple wires off one of these LEDs, and we'll see how much of a difference there is in voltage when the alarm starts going off. Alright, so I've just soldered a couple component legs onto that LED there, and hooked up my scope to it. The reason why I decided to hook up the scope to it is I'm kind of expecting this to be PWM. Alright, so surprisingly it's not actually PWM, it is using a solid line there. Hopefully if I talk over this thing I don't get a copyright strike or something like that. I think I just bumped the probe there, that's why I did that. But you'll notice I'm at 2.63 volts RMS right now. Of course it's just DC voltage. And if I turn it off, there we go, 2.57, so there's not much of a difference there. Anyhow, now that I've at least proven that it's not PWM, I'll hook up a real meter to this instead of an oscilloscope, and we'll see what that says. Alright, so if we actually do some math on that voltage here, it turns out that we only have about a 66 millivolt difference in between the upper and the lower limits of that. And of course there's an at for everything, so we have a 10-bit resolution ADC with 0 to 5 volts. That would be, well, it would match the Arduino. And you should see a ADC value jump of 13 out of 1,024. So anyway, I'm thinking probably hook up a real Arduino to this and see what happens. See how stable it is mainly. But I'll go ahead and do that. Alright, so here's the setup. I've just got my Arduino Leonardo set up over here as a just to read the analog pin A5, and I've got the positive, that LED, hooked up to the analog pin, and the negative hooked into the negative rail, and I am consistently getting 528. It's dipping to like 527 every once in a while. With the backlight on the dim mode, if I turn it on, it jumps up to 542. Really, with as consistent as it is, it shouldn't have any issues doing analog read here. It's varying like 541, 542, but that should be good enough for sensing whether the alarm's going off or not. So the last thing to do with this alarm clock is to hook up a cable, or probably drill a hole in the back of this thing, and run a cable out of it. So yeah, I'm gonna start working on that. Alright, so here's the finished alarm clock. Still looks pretty good, though there is one little strand of hot glue behind that little piece of plastic. There was one big one behind it the first time, and I had to get rid of that, but that little one's not going to bother me too much, especially because it's out of the way. But in the back here, I've got this 3 wires coming out. I've got 5 volts ground and that actual signal from the LED. And that is a LiPo balance plug there, 2S LiPo balance plug. And I just happen to have these extension cables laying around to be able to cut up. So, anyway, I got the other end of that matches that connector. But, anyhow, that's the modified alarm clock. The next part of this will actually be building the circuitry in order to make our artificial sunrise. So, that's it for part 1. See you in the next part, guys. Bye.